Super ada.
Begini? Begini?
Oh ya bakli. Hi all of you. In the previous class we have seen some terminology come in the case of lenses. Now in this class let's see ray diagrams for the formation of images by convex and concave lenses. In the previous class we have seen the behavior of incident light rays incidenting on lenses. So we know the refracted light rays of some incident light rays. With the help of those we can draw the images for the objects by convex and concave lenses. So let's see how we draw the ray diagrams for the formation of images. So the first one is when the object is at infinity. When the object is at infinity, the light rays coming it are parallel to each other, and if they incident parallel to the principal axis, after the refraction, convex lens can converge all those refracted light rays at a focus. So here all refracted light rays are converging means at a focus there is a image can form. At focus image form. So here the distance from lens to object is called as object distance. So here object distance is infinity, and the distance from lens to image is called as image distance. When the object is at infinite distance, so convex lens are forming its image at its focus, and we know the distance from lens to focus is called as a focal length. That means when the object is at infinity, the image distance is equals to focal length of a lens. So here image distance and both the focal length of a lens are the same. Here, okay, this is the point image of a point object. This is the point image of a point object. So here we use two types of objects, point object and extended object. Point object means point size of object is called as a point object. Extended object means that is which has dimensions is called as a extended object. Dimension means like a breadth or a height or a width or etc. An image which has a dimensions is called as a extended object. Now let's see in the second case when the object is beyond C2, beyond the center of a curvature. When the object is beyond the center of curvature, so here let's take an extended object. So one is incident light ray. It is incidenting parallel to the principal axis on a convex lens. After the refraction, it should pass to the focus. So it is passing to the focus. Let's take another incident light ray which is passing through the optic center. The light ray which passes through the optic center without any deviation, it refracts in the same path. This is the refracted light ray of this incident light ray. And these two refracted light rays are intersecting at this point. Now draw a normal from principal axis to this intersecting a point, and this is called as a image of this object. When the object is beyond the center of curvature, convex lens can form its image between focus and center of curvature. Now let's see what are the characteristics of the image formed by a convex lens when the object is beyond C2. See, it is inverted when compared to object. Okay, so object is in the upward direction, it is erect, whereas image is in the downward direction, it is inverted, and it is called as a real image. So here we are having two types of images, real image and virtual image. So real image means an image which can caught on the screen is called as a real image. Virtual image means which cannot cut on the screen is called as a virtual image. For the real image, we need a screen, whereas for a virtual image, we don't require any screen. We just look through the device. We look onto the device, then we can see the image of an object. Now see here, this is the real image. Okay, we can see this image of this object when we take a screen at this point. When we take a screen at this point, we can see a very clear-cut image of an object. So this is called as a real image. Or else there is another definition for the real image. Suppose if the image formed by the actual passing of a light rays is called as a real image. So here through this image point, the refracted light rays are passing and forming the image. So this is called as a real image. And see here, it's a size. It is diminished. That means when compared to object, its size is less. When the size of image is less than the size of object, then we call it a diminished image. And the position, see here, the position of image is between focus and center of curvature. When the object is beyond the center of curvature, convex lens can form its image between focus and center of curvature on the other side of a lens. That is. Now, let's see the third case. In the third case, when the object is at a C2 on one side of a lens, when the object is at a C2, then convex lens can form its same size of image at the same distance at C1. Okay, so to form the image of this object, so here we took two incident light rays. One is parallel to the principal axis and another one is passing through the optic center. After the refraction, these two refracted light rays intersected at this point and we drawn a perpendicular from principal axis to this intersecting point, and this is called as a image of this object. Now here, let's see the characteristics of image. So no doubt, it is inverted when compared to object. It is also real image because through this image, the actual light rays are passing, and here its size is same size as a object. Here the size of image is same as a object, and the position is at a C1. So this is a very important case. Okay, suppose when the object is at a C2 at one side of a lens, then convex lens can form its image at a C1 on the other side of a lens in the same dimension. That means in the same size. So this is very important. So differently they ask the questions in this case. Suppose for what position of an object, okay, we can have the same size of an image. When the object is at a center of curvature, then we can have the same size of an image at the center of curvature on the other side of a lens. Suppose if the focal length of a lens is 15 centimeter, for what object distance we should have the same size of image and the same image distance. So here focal length is 15 centimeter, okay, and the distance from lens to center of curvature is what? 15 into 2, that is distance from lens to center of curvature is called as a radius, and radius is equals to twice the focal length, 30 centimeter. When the object is at 30 centimeter, then the image distance is also 30 centimeter, then the image size is also 30 centimeter. So here, like differently they will ask, so we have to identify this case, and we have to, according to that, we have to give the answer. Okay, so this is a important case. We get the same size and the same image distance when the object is at the center of curvature at one side of a lens. So this is a case third. Now let's see here the case in that when the object is between a focal length and a center of curvature at one side of a lens. At one side of a lens, see here, object is taken between a center of curvature and a focal length. Between the center of curvature and a focal length. So here, okay, so these are the two incident light rays taken from the object. So one is parallel to the principal axis and another one is passing through the optic center. Here, the refracted light ray of this one is passing through the focus and it is incidented at the optic center. So without any deviation, it is passing in the same and these refracted light rays of these two incident light rays intersected at this point. Now we drawn a perpendicular from the principal axis to this intersecting point, and this is the image of this object. Now see here the characteristics of image found by convex lens of this object. So it is also no doubt inverted when compared to object, and it is also real image because when we use the screen here, then only we can see the image of object, otherwise we can't see. And see here in dimensions, the size of the image is enlarged when compared to the object, and the position of image is behind C1. So these are the characteristics of the image found by a convex lens when the object is between C2 and F2. Now let's take, so here next case. In this case, when the object is at a focus, let's take two incident light rays. One is parallel to the principal axis and another one is passing through the optic center. Okay, so one is parallel to the principal axis. After the refraction, the refracted light ray should pass through the focus, so it is passing through the focus, and another one is passing through the optic center, so without any deviation it refracts in the same path. See, these are the two refracted light rays. Okay, so here when the object is at a focus at one side of a lens, the refracted light rays are parallel to each other. So here the refracted light rays are parallel to each other means, okay, so maybe they converge at infinite distance. That means at an infinite distance a real image form. That means when the object is at a focus at one side of a lens, then a convex lens can form its image at infinite distance, and it is a real image. So these are the few cases, okay, ray diagrams drawn for the formation of images by convex lens. Now let's see the next case. The previous 5 cases we have seen the formation of an image by convex lens. In all those 5 cases, the image is a real image. Now let's see when the object is between focus and optic center. When the object is between focus and optic center. Now see here, when the object is between focus and optic center, okay, let's take two incident light rays. One is parallel to the principal axis. So after the refraction, it passes through focus, and let's take another one which is passing through the optic center. After the refraction, without any deviation, it should pass in the same direction. But see here, these two are the refracted light rays of these two incident light rays, but these two refracted light rays are moving away from each other. So traveling away from each other. That means there is no chance of intersecting of these refracted light rays. Okay, if these two do not intersect and they don't form any real image, that means there is no chance of formation of real image of this object on the other side of a lens. So for this, let's extend the refracted light rays of these two. So these are the extended refracted light rays, and these two extended refracted light rays intersected at this point. Now draw a perpendicular from principal axis to this intersecting point, and this is called as image of object.
unlike to previous cases. So here the image formed on the side of object only, and here through the image no light rays or no actual light rays are passing, and here the image formed is by the extended refracted light rays. So this image is called as a virtual image. Virtual image. That means here we don't need to take any screen. Just when we look through a lens, then we can see it's a enlarged form image. So this is the virtual image. Virtual image. Okay. Now let's see characteristics. So it is erect as a object. Characteristics is one is erect image, and it is enlarged image, and it is a virtual image, and its position is behind the lens, or else on the same side of an object. On the same side of an object. Okay. So this case is very different when compared to previous cases. In all previous cases, convex lens formed real images, whereas in this case, convex lens forming virtual image. Okay. That means when we take the object very close to a lens, that means when the object distance is less than the focal length, then convex lens can form its virtual image on the same side of object, erect form enlarged image. Okay. So depending upon this case, we use the convex lens as a simple microscope. Okay. Simple microscope means, so it is used to see the objects in the enlarged form, to see the smaller objects in the enlarged form. That means convex lens is used as a simple microscope when the object lies between focus and optic center. Okay, the characteristics are erect, enlarged, virtual image, and the position of image is behind the lens, or else on the same side of an object. So this case is very, very important. So here convex lens can form virtual image in one case only, and that case is when the object is between a focus and a optic center. In the remaining all cases, convex lens can form real images. From this we can conclude that convex lens can form both real images and virtual images. Convex lens can form both real image and virtual image. Okay, in which case virtual image, convex lens can form virtual image? In a case when the object is between a focus and optic center. In the remaining all cases, convex lens can form virtual images. Now let's see here ray diagrams, formation of ray diagrams for the formation of images by concave lens. So let's take here concave lens. In front of the concave lens, let's take a object. Okay. So to draw the image by the concave lens, so let's take two light rays. One is parallel to the principal axis. It is incidenting parallel to the principal axis on a concave lens. After the refraction, it refracting as it is coming from a focus. Okay. Let's take another light ray which is passing through the optic center. When light incident at the optic center without any deviation, it passes in the same direction. Okay. Now here these two refracted light rays are diverging. That means traveling away from each other. There is no any chance of intersecting of these two light rays and forming a real image. So that's why. So here I am extending the refracted light rays to back. So this is the extension of this refracted light rays, and this is extension of this refracted light rays. And here the extended two refracted light rays intersected at this point. Now draw a perpendicular from principal axis to this point, and this is called as a image of this object. Now see here, okay, so here we are not using any screen to see the image. We can just see this image by looking through a concave lens. So here we are not taking any screen, and here image is forming by the not actual light rays, and here the image is forming by the extended refracted light rays. So that's why it is called as a virtual image. It is the virtual image. We don't need any screen to see this. Okay, just when we see an object through a concave lens, okay, we can see its diminished erect image. So in the case of a concave lens, wherever the object, concave lens can form its image between focus and optical center. Okay, as you change the object distance in front of a concave lens, okay, the position of image also changes, but between a focus and the optic center only. Okay, so concave lens in any case, concave lens can form only virtual image. Concave lens can form only virtual image. Concave lens can form dash: A, virtual image; B, real image; C, both; D, none. A, virtual image only. Concave lens can form only virtual image, whereas a concave lens can form both a real and virtual images. Okay, so these are the characteristics of an image formed by a concave lens. Okay, so no doubt it is erect. Okay, it is erect as compared to object, and it is diminished. It is diminished